I'm going to show you how to work the total surface area of this triangular prism. Now what I'm not going to do is work at the volume, and that's a separate video. Now you need to consider how many faces this triangular prism has. If you look at the animation, if I open this up now, you can clearly see now there are 2 triangles and 3 rectangles. That's the net of a triangular prism. What I'll do is work out each and every face. I'll start off with the bottom one. It looks easy enough. You can start off with anything you want. You can call it, you can label it whatever you want. Call it the bottom face. It's a rectangle. It's got 10 and 8. 10, 8. 10 times 8 is 80. That's the bottom face done. What else shall we do? We can do the 2 rectangular faces, the 2 slopes, right? The slopes, they are identical. Well, how do I know they're identical? How do I know that this rectangle is identical to this one here? If you look at this diagram, this is an isosceles triangle. I know it's an isosceles triangle because of those 2 marks there. This means if this is 5 centimeters, this is also going to be 5 centimeters. And this is 10 over here, so that's going to be 10 as well. So it'll be 10 this way for that one, and it'll be 5 that way. So that'll be 5 by 10, and this one will also be 5 by 10. I'll repeat, 5 by 10, and then this rectangle 5 by 10. They are the same. I'll call this, what shall I label this? You can call it what you want. I'll call it the right face or the right slope. It's a rectangle, 10, and what's that? It's going to be 5. 10 times 5, 5 times 10, 50 centimeters squared. Therefore the left one will also be 50 centimeters squared. Right, what else is there left over? I've done all 3 rectangles. Now I'm going to do the triangles. Both triangles are the same size. It's got a vertical height of 3. Vertical height of 3. And it's got the base as 8. To work at the area of a triangle, it's base times height divided by 2. Base times height divided by 2. That will be 24 divided by 2, 12 centimeters squared. That's the front, and obviously the back, that one there, will also be the same as the front. The back will also be 12 centimeters squared. Now to get the total surface area, you need to add up all the areas of each faces. I've got 204 centimeter, not cubed. Remember, we're working at surface area. It's going to be centimeter squared. They could have made it slightly more challenging by not giving you the vertical height. Remember, without the vertical height, you cannot work out the area of the triangle. So then you start thinking, well, what topic do I need to use to work at this vertical height? Remember, this is an isosceles triangle because of those 2 marks, and that line is obviously a line of symmetry. So this triangle and this triangle are the same size, they're congruent. If I just highlight that for you, this is the triangle. Let me just draw that triangle for you a little bit bigger. Since that's coming right down the middle, that length here, half of 8 is 4. And I want the vertical height, this vertical height. So you think, what topic do I need to use to get a height? You can't just do 5 add 4 or 5 take away 4. There's got to be a way. Remember, this is a right angle triangle. And the topic that I'm referring to is Pythagoras. The longest side is given to you, but I want to work out one of the shorter sides. One of the shorter sides is given, but I want to work out the other shorter side. And for that, what you do is square root, big number first, 5 squared. Because we're trying to find the shorter side, it's minus. If it was a longer side, it would have used a plus. Anyway, we're trying to work out one of the shorter sides. That's a minus 4 squared. So you do that on the calculator, or you could do that without a calculator in this case. 5 squared is 25, take away 4 squared is 16. 25 take away 16 is 9. Square root of 9 is equal to 3. So the vertical height is 3. Once you work out the vertical height, you can work out the area of the triangle.